Dear students, in the last class we have studied an expression for the period of oscillation of a compound pendulum. And the period of oscillation of a compound pendulum, T can be represented as T is equal to 2 pi into root of 1 by G into K square by H plus H, where H is the length of the pendulum and K is the radius of gyration. And consider a simple pendulum which has the same period as that of a compound pendulum, and let T be the period of a simple pendulum. Then T is equal to 2 pi into root of L by G. And comparing these two equations, then we get L is equal to K square plus H square divided by H, or L is equal to K square by H plus H. And this length L is called the length of equivalent simple pendulum. That is, a simple pendulum which oscillates with the same period as a compound pendulum is called an equivalent simple pendulum. In the case of a simple pendulum of length L, the period T is equal to 2 pi into root of L by G. And for a compound pendulum oscillating with the same period, T is equal to 2 pi into root of 1 by G into K square by H plus H. And comparing these two equations, we get L is equal to K square by H plus H, and this length L is called the length of the equivalent simple pendulum. And next is the center of oscillation. And figure shows a cross section of a compound pendulum. Here O is the center of suspension and G is the center of gravity. And the distance between the center of suspension and the center of gravity is called the length of the pendulum and is represented by H. And produce the line OG to C such that GC is equal to K square by H. Then the point C is called the center of oscillation. Hence the distance OC is called the length of equivalent simple pendulum. That is, OC is equal to K square by H plus H is equal to L. That is the length of equivalent simple pendulum. Show that the center of suspension and center of oscillation are interchangeable. And consider the cross section of a compound pendulum. Here, let O be the center of suspension and C is the center of oscillation. And let T be the period of oscillation about the center of suspension. And then the period T can be represented as T is equal to 2 pi into root of K square plus H square by GH, or T can be represented as 2 pi into root of 1 by G into K square by H plus H. And consider the second figure, that is, let T dash be the period of the compound pendulum about the center of oscillation C. And in this case, the distance between the center of oscillation and the center of gravity, that is the GC, it is H dash. Therefore, the T dash can be represented as T dash is equal to 2 pi into root of 1 by G into K square by H dash plus H dash, where H dash is K square by H. That is, T dash is equal to 2 pi into root of 1 by G K square divided by H dash is K square by H. That is, T dash is equal to 2 pi into root of 1 by G into H plus K square by H, or T dash is equal to 2 pi into root of K square plus H square by GH. That is, T and T dash are equal. That is, the center of suspension and the center of oscillation are interchangeable. Minimum period of oscillation of a compound pendulum. And we know that the period of oscillation of a compound pendulum T is equal to 2 pi into root of 1 by g into k square by h plus h. And the value of the period t is minimum when d by dh of t is equal to 0. That is, in the equation h is the variable. That is d by dh of k square by h plus h equal to 0. And this can be written as d by dh of k square into 1 by h plus dh by dh, that is equal to 0, or d by dh of 1 by h is minus 1 by h square. That is, we know that d by dh of h raised to minus 1 is minus h raised to minus 2. That is k square into minus 1 by h square plus 1 equal to 0, or this can be represented as minus k square by h square plus 1 equal to 0. That is minus k square by h square plus 1 equal to 0, or k square by h square equal to 1, or k is equal to h. This is the condition for minimum period. Therefore, substituting this condition k is equal to h in the expression for the period, then we get the minimum period t minimum is equal to 2 pi into root of 2k by g.